Now, let's see the multiplication of a vector by a scalar. So we multiply a vector with a scalar. And let's also discuss equal vectors and parallel vectors. Okay, so let's first discuss the multiplication of a vector with a scalar. So the multiplication of a vector v, okay, by a scalar k. Okay, so v has a magnitude and a direction, but k is a scalar. So you're just multiplying k with v. So the multiplication of a vector v by a scalar k is a vector. So the multiplication of a vector and a scalar results in a vector. So let's just see a vector into a scalar is equal to a scalar. So that's one thing to note, okay? And it is a vector whose magnitude is k times that of v, and it is denoted by kv. Simple. So basically you're just increasing the magnitude of the vector v by k. Simple. So if k is positive, then v and kv are in the same direction. Obviously, because let's just say you have a vector v which is equal to, let's say, -2, right? So if you have a scalar k which is basically equal to, since it is positive, we're discussing the positive first, so k is equal to, let's say, 4. So k v is equal to -2 into 4, which is equal to -8. As you can see, both v and kv are negative, so they're in the same direction, right? But if k is negative, then kv and v are in the opposite direction. So let's just take this, let's just take two other vectors. So let's just say in this case, v is equal to, again, -2, okay? And let's just say k is equal to -4 instead of +4. So when you have k v, that will be equal to -4 into -2, which is equal to +8. As you can see, v is negative, but kv is positive, right? So v is in the negative direction and kv is in the positive direction. So they're in opposite directions. I hope that clears things up. So let's discuss equal vectors. So two vectors a, b are said to be equal if they have the same magnitude and the same direction. So this is equal to this. So the modulus of AB is equal to the modulus of CD, which means that they have the same magnitude, and A to B is in this direction and C to D is also in the same direction. So basically there is no difference between this vector and this vector because they have the same length, which means they have the same magnitude and they have the same direction. A is the initial side, it is down, it is below B, and C is also the initial side in the other case and it is also below D. So A to B, B is the terminal side, and in the other case D is the terminal side. So both vectors are equal in magnitude and they're also in the same direction. That's a very simple concept, really. If both vectors are the same, they look the same, they are the same. So let's discuss parallel vectors. Now, two vectors are parallel if and only if they are non-zero scalar multiples of each other. So they can be in opposite directions, because let's just say this is vector AB, right? AB. And this is negative AB because it is in the opposite direction to the original vector AB. But it is a scalar multiple because negative AB is just -1 into AB. -1 is the non-zero scalar multiple, right? So AB and negative AB are scalar multiples of each other. So they're parallel vectors. And another example is this, 3/2 AB. The magnitude of this vector is greater than that of AB, but it is a scalar multiple. So basically 3/2 AB is simply just 3/2, which is a scalar, into AB, which is the vector. And so, since it is a scalar multiple of AB, it is parallel to AB, since it has the same direction, right? It's just the simple rule to remember is that two vectors are parallel if and only if they are non-zero scalar multiples of each other. Simple.